Modalities are just different types of data that aren't language, but are still very important. In the medical field, a modality might be an MRI image. In the case of a robot, a modality might be the feedback that a sensor on the end of an actuator for a robot arm is feeling. The signals from some conveyor belt on the assembly line in a factory. The generative models that we've developed for language seem to be just as adept at learning from those types of signals and those types of modalities. Generative AI can learn from the language of humans, that they can also learn from the languages of nature.
Right.
And that's just incredibly exciting.
So we've been talking about business transformation with generative AI, and the focus has, to this point, been on language models, generative pre-trained models, and the mode of communication that we use with words, both in writing and speaking. But there's a lot more going on in the research and the practicalities of these things. Talk about, Vijay, the kind of conception of more than one mode and what that includes. What are we talking about here for these new models?
So certainly from the business transformation lens, I want to sort of firstly separate out fields like healthcare and pharma and even energy. They've always understood there are multiple modalities, and we can go into that a little bit later. But when people have traditionally thought about business process transformation or business transformation, it is transformation of words.
Right.
And a few numbers. And language really fits completely there. And we've created these beautiful ERP and CRM systems and productivity systems where we type something in, or maybe somebody inputs and quickly gets translated to words. And after that, they stay as words. And if I have to instruct somebody to move an item from warehouse A to the truck, the words go out. The rest is not my problem. And yet we know that every single thing that happens in life actually emits multiple signals. Right. We've got signals now, not just in words, but posture and gait and the ambient noise and lighting and the fact we are casting shadows. Amazing amount of signals, and we're just ignoring those. So what I've found is that people who have practiced with generative AI, and really not just GPT-4, but DALL-E, for example, has done a lot of good, because people are generating logos, generating all kinds of interesting visuals, and their point is, well, okay, now I will be able to interpret all these signals. So this is really causing very, very interesting thinking to people. Like, what is my process? Is my process when I tell somebody to move item from warehouse A to the truck? Or is my process much further, all the way down to the customer's kitchen? Does my process start only when the order comes in on e-commerce? Or is it even in the life of my consumer? So basically, that's just sort of, it's that profound.
Yeah, these are
for
big
those people who are
philosophical
thinking about
questions for businesses.
So I'll hand it to Peter, because really we should distinguish the general business process transformation or business transformation even from fields which are already much further ahead. Then we can draw some lessons from those.
Yeah, from the computer science research perspective, there's just tremendous excitement. And it's hard to express just how exciting AI research is today. Everything that you see in something like GPT-4 is really based on just three ideas. There's the idea of a computer science mechanism, which is called attention, and that has a very technical meaning. But the technical use of the term attention actually relates to our normal meaning of the word attention. It's a mechanism that allows a system, an AI system, to know what to pay attention to, what's important, and keep context. Then there's this concept of something called self-supervision. So it used to be to create these AI systems, we had to have human beings in the loop and labeling and grading the outputs and so on, giving feedback. But now the bulk of the base training of an AI system can be done by the system itself. And then the third is the realization that that there are scaling laws. Basically, the bigger, the smarter. And it's amazing that just those three ideas are leading to everything that we're thinking about now. But there's so much more that is going on now. People are thinking hard about, can we endow these systems with autonomy and allow them to act as agents? Can they be a part of this conversation and just participate? How can we have much better memory? We don't have perfect memory from our childhoods, but we remember a few key episodes that have shaped who we are, and we can resurrect those things. We have AI systems that have similar kind of episodic memory. But now, to Vijay's point, and I think the subject of this session, are these modalities. Modalities are just different types of data that aren't language, but are still very important. In the medical field, a modality might be an MRI image or an ultrasound image. In the case of a robot, a modality might be the feedback that a sensor on the end of an actuator for a robot arm is feeling. A modality might be the signals from some conveyor belt on the assembly line in a factory. All of these are different types of data that so far AI systems haven't been exposed to. But what is so exciting to us as researchers is that we are learning over and over again that the generative models that we've developed for language seem to be just as adept at learning from those types of signals and those types of modalities. And so that is just opening up all sorts of new possibilities. In the way that our CEO, Satya Nadella, has put it, in the same way that we've shown that generative AI can learn from the language of humans, that they can also learn from the languages of nature.
Right.
And that's just incredibly exciting.
Well, and even at the beginning when we were talking about this multimodal model, my mind automatically went to video, pictures, just thinking of what humans, how they communicate. And we talked about there being so many more modes of communication. And even as you're talking, Peter, I'm thinking of haptics. Early on, that was like, oh, we can do touch with computerized systems. So Vijay, talk a little bit more, kind of compounding on Peter's points. Where are these modalities most important for businesses?
So let's just start with something which is important for society, and sort of then we can talk about how businesses take advantage of that. So one of the scenarios I've been sort of like really exposed to is maternal care in certain emerging countries. And there are norms about what the female can say or says and doesn't say when the doctor asks a question. Because often those questions are in front of other people, maybe family members. And also people put a brave face. But the beautiful thing is an experienced doctor, a really experienced doctor, knows how to interpret all the signals.
Interesting. How
do we get everyone else, other than that scarce resource, up to par? Well, if the only thing I'm looking at is a transcript, I'm not going to get there. So just at a very profound level, the human condition itself changes if we can bring intelligence actually into real situations. So we can go into other examples, but that itself is a very interesting one for me.
I can't restrain myself. I need to brag about some things that we've done in our lives. But I want to be clear. There are great laboratories around the world that are doing amazing things right now. But if I could just brag about a couple of things from Microsoft Research. First off, when we talk about generative models, we've been talking about the next word prediction models that we see in something like ChatGPT or GPT-4. There's another type of generative model which are called diffusion models. And if, Vijay mentioned DALL-E, if you used DALL-E 3 or Stable Diffusion or Midjourney, you've experienced a diffusion model, which is able to take your verbal prompts or text prompts and make a picture from it. Those two ideas, when applied to other modalities, let's take the example of finding a small molecule that might have an ability to bind to a drug target and then have an inhibitory effect in order to prevent disease or cure disease. What we have discovered is that you can use a diffusion model to generate a huge catalog of possible molecules that would potentially bind to that drug target, and then a generative model from there to make the accurate prediction of, out of that catalog, which one of those small molecules would have the inhibitory effect.
Interesting.
And this has now been tested in several cases, design cases, to find small molecules to support de novo drug design. And by golly, it works. And this has just electrified the research community, and there are now laboratories around the world chasing after this. Similarly, think about taking decades of historical global weather data, and now asking the question, in the next hour, what is the likelihood of a severe weather event forming? This is now in a model called Aurora. And what we discovered is not only can you make predictions almost a week in advance of the likelihood of a severe weather event forming in some part of the world, and you can do so at levels of accuracy that superseded previous specialized models. But because it's a generative model, it's what's called foundational. Mm-hmm. And that means that that same model can then be used for other tasks that are related, such as predicting where air pollution patterns are likely to migrate from region to region around the world. And again, do so at levels of accuracy that haven't been seen before. And so these are just the earliest kinds of examples. And there are hundreds more emerging out of laboratories around the world. And, they are every bit as amazing. But what is really just tickles me as a computer scientist and AI researchers is that the fundamental neural architecture is the same as what we see in something like ChatGPT or Microsoft Copilot.
Okay, so as you train a language model, you use words and data from word sources. What about these other kinds of modes?
When we say multimodal, that's the idea of combining these things together. Yeah. And the easiest multimodal situation to think of is to take one of these modalities and integrate it into a language model so that you can start having a conversation with an AI that maybe knows about small molecules.
So you're extending the LLM's capabilities.
Right.
Okay.
Now, just as a technical matter, even us as computer science researchers use the term multimodal, but broadly speaking, the models that are available now are only bimodal. In other words, they can do images and text, or videos and text, small molecules and text. OpenAI actually has made significant advances, and so their latest GPT-4o, which stands for Omni model, is a truly multimodal. In other words, it can accommodate more than two modes simultaneously. But even just the bimodal situation can be pretty amazing, yes.
Yeah. Well, and that kind of speaks to the next thing I want to talk about, is that most of the time when we interact with an AI, currently, it's on a screen. It's digital. And some of what you're talking about sounds like it's more embodied AI. It's out in the world. It's collecting data from other places and other sources. So where do you see the research and the practicality for businesses going as AI models move off your screen and into the world?
We have seen over the last 40, 50 years where You had PCs and the internet and servers and then cloud and with mobile devices and so on. An incredible change on how people behave. They used to go to a store. That's when the experience started. When they left, the experience ended. So entire facets of life were completely free of computers, or at least computer systems. I'm on a construction site.
Yeah.
The computers are in a corner in a hut.
Or a farm.
Or a farm.
Right.
Right? Or an emergency site, at the side, an accident at the side of the road. There is no assistance over there. In a wildfire, people are now bringing drones in there. There is nothing. So basically, we completely perfected two things. One is transactions, which is I buy, I sell, I order, I deliver, I got it.
On a screen.
On a screen, because it lends itself to being digitized. And the other thing we perfected is content, which in my opinion is a derisory term for richness of modalities. It's like it's content. It's you just watch it.
I'm so glad you said that.
And that's what we perfected. And we created trillions of dollars of value for society. And basically, everything that didn't lend itself to that constriction, to a narrow stovepipe, we left out. How do you design, so these are real examples, design an urban center with a playground that will be free of, if like criminal risks and so on. And those things really are completely undigitized. So we are going to see a new kind of, if you like, intelligence, but digitization of life, and you don't have to trick them out with sensors. Because my eyes don't need sensors to be in every place. So simply the fact the information's already there should allow me, in most cases, I mean, I still have to understand a molecule via an electron microscope or whatever it is, but basically we are going to see, and that's what, the lowest hanging fruit is. For every business I talk to, the point is, we could not do this. We always wanted to. It eats up most of our time. That's where most of the mistakes happen. That's where we need to get other people to tell us signals. Now, I can be part of that fabric.
Right, right.
To your robotics question, one of the things that the people watching this video might, a technical term they might be hearing more about in the near future is something called large action models, LAMs. And when you're dealing with a large language model, there is an interaction between a human being or an AI and the LLM. So the human being makes a prompt, there's a response, and things go back and forth. In a large action model, for example, in a generative AI system that's controlling a robot, there might be a human that's asking the LLM to put the dishes away. The generative model is deciding I need to send a command to move the robot arm and actuator to grab a dish. But now there's a third input, which is the feedback of how successful that was, how heavy the dish is, how slippery it is, that has to also be part of the input into the cycle. And so you can abstractly think of a large action model as having a third actor, which is forming that quick sensor actuator feedback loop. And this is also something that I think the most advanced large action models we see in the world today are in the self-driving cars, where there is a similar...
I was just going to say, what's the difference between a large action model and a robot?
That's right. And so if you think about the AI that is going to drive your car automatically somewhere, again, there is the human prompt that says, I want to get from A to B, but there has to be this constant feedback loop, this constant set of sensor to actuator kind of feedback in order to navigate down the road and avoid hitting cars and pedestrians.
So there's the digital space and there's the physical space, but part of the hope for AI models is that it would even do more and better for this digital space through software development and app development and so on. So, and that's an actual business opportunity unto itself. So what do you guys see in terms of where these generative AI models are going in terms of development?
Today, when you develop what's commonly called multimodal, which by that we mean images and video, maybe speech or sound, rather music, along with data, structured data, it's very simple that all the logic is inside the structured data. And every now and again, I play a video, I bring up a photo, or I trigger certain music. That is the app development model today. What we really need is a development model which says if the music and the gait or posture of people goes in such a way that they're not keen on the subject, change something. So we don't have today an application development model that actually understands modalities. So we can mix data. I can take a table from SQL database, and I can take a table or a section of an XML file. I can put them together. I have those abilities. But I cannot take and easily put air quality along with lighting. I just cannot do that today. And that's really the promise of generative AI, because it's not just understanding one or the other, but the connections between them. Yeah. So we now need to be able to design applications that are actually taking advantage of the correlation between modalities or the complementarity between modalities, as opposed to orchestrating each through external logic.
You know, there is a sense in which in a world of very intelligent AI that we're heading into, that the idea of an app starts to fade away. Now, in the consumer space, apps are a very big business, and app stores are a very big business. And so I think apps will be with us for quite some time. But if we put that business imperative aside for a moment, if you had an AI that was intelligent enough, you would just have a machine. You know, your computer here would be just a machine that does what you ask it to do. So, you know, if maybe you wanted to arrange for a birthday party for your child, instead of trying to figure out, you know, what apps exist in an app store, downloading those apps, finding them on your home screen, double-clicking on them, making accounts, and then, you know, figuring out all that stuff. Instead, you would just ask the AI in your device, hey, you know, my kid's having a birthday, I want to arrange a party, you know, what are your thoughts? And then can you help make those arrangements? Now, while the consumer space may not get there very soon, the enterprise space could be different because there can be value in current application suite offerings for companies, you know, to, in essence, kind of put an AI umbrella over the whole thing. One example, as we've mentioned in the previous session, is about the electronic health record company Epic, where an Epic system is really a collection, a large collection of lots of applications. And there's complexity in all of those things. And you can imagine that at some point there may be an AI which is just the clinician's assistant. And there would be tremendous value, there would be tremendous stickiness for Epic, but also tremendous value for the users of that system. And so the whole idea of an app, I think, is different. One other thing to say is that it's not exactly a modality, at least we never thought about it that way, but the very first generative AI product that Microsoft developed jointly with OpenAI was GitHub Copilot. Right. And GitHub Copilot has advanced tremendously now, and if anyone listening to this hasn't had their developers using GitHub Copilot X, they should, because it is magical. The ability of a generative AI system to give a tremendous productivity boost to any software developer, to any programmer. even for an old guy like me, it has given me new life to be able to write software code again. And that is just something that's been, I think, tremendously magical.
So we started our conversation on sort of big futures and transformation of business, and we've got into healthcare examples, we've got into some other business examples, and I still feel like we're early days on AI transformation writ large. So let's say language models they're riding the top of the wave right now. They're not in the curl yet. They haven't kind of landed on the shore, but out here, still waiting for the multimodal wave coming, are the companies. How then can they start to think about applying tomorrow technologies in their today businesses? And what kinds of things ought they to be aware of? And by they, I mean people who just don't understand where it's going to go.
So one beautiful example that I've seen where people are actually working on this, this is a company that creates drugs for chronic diseases like diabetes, kidney, and so on. And every time you have a strong drug, especially the one that affects the immune system or whatever, you see a whole host of side effects listed on the prescription. But the point is the side effects are there because you cannot change the dosage with feedback. And it's surprising how many of those side effects go away if somebody had a physician next to them with all instrumentation, which of course is impractical. So now there are micro dosing pumps, and there are, of course, people have Apple Watches and other sort of instrumentation. So they are rethinking the role of the drug and what is the drug. Is it a fixed dose, or is it something that's adapted? So basically, it's very profound way that you can rethink even today's products.
Right.
Yeah, you know, it's such an important question, Gretchen, and I think from the seat of a CEO, you have to think about where the leverage points are that would really help position your people and your assets to be best positioned to take advantage of any breakthroughs that are coming down the pike, and understanding that it's impossible to predict when and what those might be. Look, I'm in that same position. I'm not a CEO, but I am morally the CEO. I'm the president of Microsoft Research, so I think about this even for research. Here's maybe one thing to share there. 15 years ago, the cloud was still not quite a thing. People were talking about the cloud as a possibility. It was a concept in the industry. And for Microsoft Research and all of our academic collaborators, the idea of doing research in the cloud was just not an idea. If it was proposed as an idea, it was sort of laughable. We were doing our research on laptops, on servers, in on-premise server racks, and so on. Zoom forward to 2024, we've just been going through a very, very detailed inventory of our research systems. And today, there are several dozen Azure services being created by researchers every week in Microsoft Research. So it's almost like watching grass grow. You don't notice it, but over these past 15 years, our research has become very cloud dependent and cloud native. And what has happened there? Well, it's not just that our research systems are in the cloud, but the fact of the cloud has changed and altered the kinds of problems and kind of ideas that our researchers attack and work on. Today, we're going through an equally profound, if not more profound shift for our research to be, let me use the term, AI native.
Right.
And I'm hoping in much less than 10 years, we will see our researchers and the choices of problems in their research systems being hopelessly AI dependent. It's very important for us strategically. And so if you are a CEO of an enterprise, you want to think about what are the leverage points that will start to get more of your organizations, more of your people, more of your teams, altering how they think about the world, altering about how they think about doing their work, accomplishing their tasks and creating success in your company around being AI native. It's a tall order, but I think that's why CEOs get paid the big bucks.
Feels like that's already happening in the sense of the slow, gradual adoption of using AI tools, and it starts in the research community and then spreads out to the business community. So, Vijay, do you have any thoughts on that slow adoption and transformation mindset-wise in businesses?
I think the DNA of researchers is, the advice, the way that Peter formulated. I don't want to corrupt it. That was the right way, in my opinion, to formulate it, which is you understood your assets, you understood your resources, but there was a mission to say AI native, which means that even the problems I address might be different. I think that's really the key.
I'm completely confident that CEOs know how to do this. A lot of CEOs that have been around for a while have lived through transformations, say, to the internet, and the fundamental alteration to business processes and the transformations there, lived through the mobile revolution. This is another one, maybe even more profound than those.
Feels like it. Yeah.